Hi guys, so this is number 17 from your chapter 7 review on page 10, where you have an improper integral, improper because we see the negative infinity and the positive infinity, as well as an expression that doesn't really come to mind what the antiderivative is. So the hint to you guys was that you were to manipulate this algebraically. Algebraically, what you could do to this function is multiply the top and the bottom by an expression of e to the x. Doing so is going to give you e to the x on top over e to the x times e to the x is e to the 2x. E to the negative x times e to the x is simply 1. So I want you guys to think about how this might look familiar, particularly if u was equal to e to the x. Then you have something similar to 1 over 1 plus u squared or 1 plus x squared. So what should come to mind is that the derivative of arctangent of x is 1 over 1 plus x squared. Okay, so here we have the squared part is e to the 2x. So if we were to rewrite this, my guess would be that this is the integral of this expression is equal to the antiderivative being arctangent of e to the x, where u is e to the x. So if we say that that is our guess as to what this antiderivative is equal to, arctangent of e to the x, again, mainly because if we ask ourselves what's being squared here, it's e to the x. So that's going to be your input where you see 1 over 1 plus x squared. Now, if we check our work, the derivative of arctangent, I would take this derivative, see if I get back to this. And so if I take the derivative of arctangent, I get 1 over 1 plus e to the x quantity squared, which gives me the e to the 2x. And then remember that we have a chain rule here. The derivative of e to the x is just itself, so times e to the x. So basically we get back to this expression, which we know is then equivalent to that expression. So now now that we've verified that that is truly the antiderivative, let's work on evaluating this. And so let me erase this. So here's our antiderivative. We're going to rewrite our improper integral so that it's proper. So that's going to mean first we're going to split. So this is going to be my antiderivative. Kind of keep that in mind. And then I'm going to rewrite my improper integral to split at 0. Dx over e to the x plus e to the negative x. Then plus the integral from negative infinity to 0 of dx over e to the x plus e to the negative x. And then rewrite this with the limit. So limit as b approaches infinity of the left integral, 0 to b, of dx over e to the x plus e to the negative x. Whereas this one is the limit as b approaches negative infinity of b to 0 of dx over e to the x plus e to the negative x. Now that we have the antiderivative, we can jump to writing and evaluating the limit. The limit as b approaches infinity of the antiderivative being arctangent of e to the x, evaluated from 0 to b. Now I'm going to go ahead and finish this left-hand limit. So we have arctangent of e to the b minus arctangent of e to the 0. And there's a limit here. And let's discuss what's going to happen. As we let b go to infinity, e to the infinity is just infinity. We now know arctangent of infinity is pi over 2. And then if we evaluate this separate arctangent expression, we have e to the 0 is 1. What is arctangent of 1? Tangent of what angle is equal to 1? And that gives us pi over 4. So this limit yields, meant to write 4. Pi over 2 minus pi over 4, which is simply just pi over 4. So all of that work was I'll just kind of separate this here, was for that limit on the expression on the left. And then what we'll do is evaluate the other one on the right-hand side, limit as b approaches negative infinity of arctangent of e to the x, integral from b to 0, plug everything in, arctangent of e to the 0 minus arctangent of e to the b. Now as we approach negative infinity, we see first arctangent of e to the 0 is 1. E to the 0 is 1. Arctangent of 1 we said was pi over 4. And then when I let e to the negative infinity, I let this, and let's think about this here. If e to the negative infinity results in 1 over e to the infinity, then I'm going to get a really small number, which then as a limit approaches 0. So what is arctangent of 0? Think of the arctangent function. It passes through the origin, therefore it's 0. And this integral results in a finite value of pi over 4. The other one resulted in a finite value of pi over 4. So together, if I add them, I get pi over 2 is the value it converges to, that the area underneath the curve from a function that is unbounded on the left and the right converges to pi over 2.